Yes, sir. So this is uh, we'll discuss all you need to know about practicals. You do not need any no more information. Okay. So AS physics practicals. This paper contains for almost 15% mark of our total grades. Okay. Idea is very easy to score high marks. Also very easy to miss the center. Okay. And so unlike other papers, MCQ or something, A grade will be very high because you know that everybody score very easy. So the thresholds will be comparatively higher than other components. So that's also one thing that we have to look out for. Yeah. Okay. So first thing, so this paper have, so we'll just discuss the structure of the paper. This paper have two questions. Okay. So first question we will have for 20 marks. Second question we will have 20 marks. Okay. So, but totally this paper have 40 marks. This will be converted to 30 marks and then added for consider for grades for AS level. So for A level, you have the equivalent paper of planning and analysis. Yes. So for 40 marks, this is the only paper they converted for mark, converted to 30 mark in AS level. All the other papers, they will just take it as it is. Okay. And these two questions, question structure will be following like this. So the question one, so you will have taking measurement. Okay. So 1 to 3 marks. So taking reading and tabular column. So this one will be 10 marks, sometime 9, sometime 8, but sometime 10. So plotting graph, 4 marks. So finding gradient and y-interceptor, actually 2 marks, but it also have effect on the other 2 mark questions, so totally 4 marks. So if you add roughly, you should get 20 marks. So question 2, so measuring 1 to 4 marks, actually 2 to 4 marks. Okay. So why here it is 1 in question number 1, why here it is 2 is this measurement will involve um, repeating evidence for repeating the measurement in question 2. So that will involve taking the average. Yes. Yes, yes, yes. Okay. And percentage uncertainty. Analytics of results. 2 results you will have. You will compare the results, 2 results. Yes, yes. So you will compare the results. You will explain. First, finding the results to mark, and you will compare the results whether that supports the statement or not. Okay. And big chunk of this question is difficulties and improvements, source of uncertainties and improvements. 8 marks. Okay, so we are going to discuss about each one of them very clearly. Okay, is it clear, sir? That's overall structure of the paper. Yeah, and in first question we have graph. Big portion of the first question is tabular column, 10 marks. So we should not make any mistake in that tabular column. Second portion, big portion is that source of uncertainties and improvements. We should not make any mistake in that part. This uh, I, hmm. Mhm. Okay, so end of this video, you will we will sort out this out. You will be clear about this. You do not need to worry about this. Yes. Okay. Yeah. Can we move on, sir? Hmm. Most for most people, it's the 8 mark questions they feel difficulty with. But once they understand what they really mean, uh, they will easily get mark. And also, it's not that easy. It's very easy to score mark in the part. Okay. Yes, sir. Okay. Uh, so we will first, before going to question one or question two, we want to understand and avoid few common mistakes in the practical. So one is significant figures. Okay. So actually, in all the other papers, in MCQ, you do not need to worry about significant figures. In theory and paper 4, significant figures doesn't matter. Okay. So actually, to some extent, examiners allow significant figure errors. But in practical, significant figures is very important, and all the answers must be given in appropriate significant figures. If they are off from the actual significant figure or the expected significant figures, despite of the right answer, they will lose the mark. So significant figure is very, very important. Okay. For, it will be wrong. Okay. I'll explain. Okay. For example, what two people, for example, people make these two common mistakes. One is giving less number of significant figures or more number of significant figures and in approximate, for example. Okay. So there is, so we have already discussed this, but I'm just reminding. Okay. There is person A. He, let's see that his age is actually 18 years, 6 months, 2 weeks, 1 day, and 2 hours, maybe 25 seconds. Actual age. Okay. Now, so B asks A, how old are you? So what's the question, sir? Yeah, okay. No, no, no. B is asking A, how old are you? Now, depend on how A answers this question, right? Let's say he is in a hurry. Is he going to answer all this data? No, okay. So A will answer. So I am 18 years old. Will he talk about month, week, or hours or second? No, okay. So this is end of the sentence. Now C asks B, how old A is. Okay. Now, can B answer 18 years, 6 months, 2 weeks, 1 day, 2 hours, and 25 seconds? So this is wrong. Why this is wrong? Because B doesn't know. There is no way in the world B know this answer. So only the except the very accept right answer is only 18-year-old. Okay. If he says 10-year, because this is round off to one significant figure, that is also wrong. Okay. But if he says 20-year, that is right. Okay. But can you see, as he says 20-year, the precision and accuracy decreases. So it's not a reliable answer. Okay. This is how the significant figures work. Okay. For example, let's say we are measuring in ruler. Okay. And we have to work out for a diameter. Now let's say that you have, so this is, let's say that you are measuring a diameter of a cylinder. Okay. So D value. Now, maybe for fun, we'll extend until here. Okay. No, yeah. Yes, sir. Can you approximately, so this is 0, 1, maybe I want to, until 0. Okay. So let's say that we are measuring bigger diameter. Okay, sir. 1, 2. Okay. So can you tell me what is answer in centimeter? Let's say that you have centimeter here. Okay. So we should write, not, if we write 2 centimeter, then this is wrong. You 1 mark. Only 2.0 is right answer. Okay. Let's say that you don't want to give this in centimeter. You want to give it in millimeter. Okay. So there you should write 20 millimeter. No, because 20.0 means, okay. So this is right, but this is wrong. 20.0 means you should be able to measure 1 more millimeter scale. Is that possible? No, it's not possible. But how can you give when it's 20 millimeter? It's right. 2 centimeter is wrong, because you can measure this next to decimal in centimeter, but you cannot measure next to decimal in millimeter. Hmm. Yeah, it will change. Okay. Depend on the instrument. Significant figures depend on the instrument. Okay. In the ruler also. Okay. Okay. Now let's say that. Okay. Now let's say that you are measuring some diameter as 15.2 centimeter. Is this reading possible? Using this ruler? Yes, it is possible. Okay. Now D is 15.2 centimeter diameter. Can you tell me the area? Okay, no, cylinder. So let's say that this is a diameter. You want to find the area of circle. Which formula you use, sir? So you use pi d square by 4, right? Okay. So we will get the actual answer 181.458. Okay, centimeter square. So how many SF this has? How many SF? What is the source of reading in this case? 3. So you should have only these 3 digits. So you should round it up to 1.5 because this is 5 or more than 5. You should amend 1. That's all. Centimeter square. Okay. Yeah, it's fine because this is 3 plus 1 is fine. Okay. You can round this up to 181 centimeter square. This is fine. Okay. 180 centimeter. This is wrong. 181.45. 5 you can round it up to 6. This is wrong. So these two are right. These two are wrong. Exact number. So the source significant figure of the instrument is called significant figure of raw data. Okay. You should give your answer in same significant figure of raw data. Okay. If raw data is 3 significant figure, you are allowed to give 3 or 4. Not 5, not 2. Okay. 3 or 4 is allowed because the fourth digit is uncertainty. That they will allow. Okay, sir? Yes. So there are some rules in significant figures. We must remember, we should recall from earlier discussion. Okay. For practical. Sir, yeah, but in Cambridge, actually, you can just amend it. Only in NEET and JE that is that rule. But yeah, but okay. So first is rounding off. So rounding off is next digit is more than 5 or actually equal than 5. Then you can just increase. For example, 18.2 can be written as 18. 18.7 can be written as 19. 18.5, if it is Cambridge, you can just round it up to 19. Okay. In general, how they will deal this is the previous number. If it is even number, they will just leave it. If it is odd number, they will increase by 1. Okay. Yeah, but in Cambridge, we can just round it up to 19. Okay. I think in checkpoint, you should learn this as bounds. So they will just increase the number just by 1. Okay. So this is the actual calculation, but uh, this works for Cambridge. Okay. So in multiplication, and division, the answer must have same or plus 1 significant figure as raw data. Sir, I think you should understand what is raw data meaning. What is the source of significant figure of the experiment? 3. Okay. Protractor also 3. Protractor actually 4. Until 4 you can measure. Okay. For example, let's say that no, 3. Protractor 3. We will discuss. Here we will discuss. 1 minute. Significant figures of instruments we will discuss. Is it clear, sir? In multiplication and division, answer must have same significant figure, or it can have plus 1 significant figure, but that unnecessary. We can just give same significant figure. And we saw the example there, right, sir? By calculating D. Okay. Yes. So if your answer is 20 centimeter, if you write 20 centimeter, it's wrong. 20.0 is the right answer. Mm. Mm. In okay. So mostly they will not ask that question. Okay, because significant figures they know if they ask in millimeter, you will struggle with significant figures. But there is another way to give it by giving scientific notation of actual significant figure. Yes. So you have to write in 10 power minus 3. So in such way, you can write 2 into 10 power minus 3, indicating this is just one significant figure. Okay. Come again, sir? No, 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 that's unnecessary. Yes. Okay. Yes, sir. So this is multiplication and division. In addition and subtraction, okay, the answer should have same, okay, decimal point as the raw data. Okay. Now you should ask this question. Let's say that I have A. This is to 4 significant figure. B, I have 3 significant figure. Now I have to do A and B. What significant figure they should have? Whichever the least of value, not a number of value, list of significant figure. The answer should have that much significant figure. Okay. Similarly, let's say that A has 2 decimals after the sorry, 2 digits after the decimals, and B have 5 digits after the decimals. So let's say that we are doing A plus B or B minus A, whatever it is. This should have which has least number of digits after decimal place. So we should have 2 digits after the decimal places. This is applicable. Yes. Yes. In the significant figure also, you will take the lowest significant figure, and in decimal place also, you will take the lowest decimal place. Okay. Fun fact is constant values like you know that pi is 3.14 or root 2 or Euler value E. These values have infinite number of significant figures. They do not add or modify your calculations. Okay, so you can take them same significant figure as your raw data. What is the significant figure of theta? Let's say that you are measuring theta to three significant figure. You will find cos theta as 4 significant figure. Let's say this also you should round it up to 3 significant figure. Let's say if angle is 178 degree or 123 degree, how many significant figure it has? It has 2. You can write just for yes. Okay. Yes, sir. Is it clear, sir? Yeah. And how about significant figure of micrometer? No, it can show up to 4 significant figures. It can show up to 2 decimal places. Because the least count of micrometer screw gauge is 0.01 millimeter or 10 micrometer. You can actually measure 12.25 millimeter in screw gauge. So how many significant figure it has? 4. So depend on your measurement, you will have 3 or 4 significant figure. Yes, sir. So depend on 2 to 3. Yes. Okay. Yes, sir. So this is about the significant figure. Sir, even if all the answers are correct, if all the answers are given to wrong number of significant figures, the person will get only 0 marks from the answers. Okay. Because in significant figures, you are not giving appropriate significant figure, means you are lying. Okay, that's the concept. So yes. Okay, so that's why most of the people lose marks. Still they don't understand why. Most of the teacher also don't know why wrong significant figure means wrong mark. Okay, yes, so that's a significant figure common mistake. I think we made it clear what to do with a significant figure. Yes, sir. So we'll discuss here. Okay, so each instrument approximately how many significant figure it will have. Okay, so for example, if we have ruler, so you can actually write millimeters. So changing the scale from centimeter to millimeter will not affect significant figure. Changing, okay, for example, you have something measured in centimeter, you convert to millimeter. So this will not affect the significant figure. Okay, but until uh 1 minute, sir. Until you can convert anything to any, yeah, you can convert any. Hello. So for example, let's say that 20.0 centimeter. Okay, this has three significant figure. Okay, so if you convert into millimeter, it's just 200 millimeter, right? But if you write like this is wrong. Why? How many SF is this has? So how many SF you should have here? But what is the possibility of writing this in three significant figure? No, 2.00 into 10 power 2 into millimeter. So this is where the scientific notation comes here. Can you see? I have converted this into three significant figure, also to millimeter as well. Okay, does this answer your first question you asked, whether millimeter scale has only one significant? Okay, but this is unnecessary for our practical accuracy. Yes. So just no, they will not ask you to convert like this in the question. If you recall, they will never ask you to convert significant figures. Okay, because they also understand student will struggle with it. But in case if they ask, this is how you should answer. Okay, so this is one. Now you must understand. For example, let's say that 0 to 9 millimeter alone, I can write in one significant figure. Okay, so from 10 to 99, I can write into two significant figure. So if I am writing in millimeter, okay. So from 100 to I think meter scale is 1000 millimeter. No. Yeah. Okay. I can write it to 3 SF. Okay. Now you should ask why in some values I can write in one significant only one significant figure or two significant figure or three significant figure. Tell me why. No, but we are measuring it, right? Sir, if you're saying 20 centimeter, this is different from 20.0 centimeter. Okay, so 0 does play the role if you put the decimal there. Do you understand? 20 centimeter has only one significant figure, 20.0 has three significant figure. Okay, the reason is, how do you find the percentage uncertainty actually? So least count divided by measured value into 100, right? So least count will stay same for all the measurement. Okay, but higher the measurement, you will have lowest percentage uncertainty. Yeah. So you can relay the experiment measurement. Let's say least count of the ruler is 0.1 millimeter. Sorry, least count of the value is 1 millimeter in the ruler. I'm just measuring 5 millimeter. Then what will be the percentage uncertainty? So do you understand this is too large to trust this error? So lower the value, okay, is the percentage of uncertainty is higher. Mm, 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 mm. Yes, see, if it, let's say that 0.1 centimeter is the lowest value, you have 50 centimeter. Okay. So if you do the calculation, 0.1 divided by 50, can you see the percentage uncertainty is only 0.2%? Okay. So the higher the value, according to your least count, is very lower percentage uncertainty. So this is because this is called relative error, least count to the measured value ratio. Okay. So can you see that this also affected by significant figure? Okay. Less digit means less reliable. Okay. That's the reason. But you do not need to worry of all this. They will not put, because if you have to measure something less than 1 centimeter or less than 10 millimeter, they will give you screw gauge, micrometer. Okay. So very important thing. We need to learn how micrometer works. Okay. So okay. So this one is called circular scale, sir. Yes. So this one is called main scale. In main scale, each one line is 1 millimeter. Okay. So how to take it? In circular scale, each one line is 0.1 millimeter. Okay. In circular scale, you will see readings from 0 to 99. In main scale, you will see reading from 0 to 14. Yeah. Okay. So first thing you should notice is, as soon as you get and see the screw guards, okay, for your practicals, let's say that if you are getting micrometer or screw gauge for your practical, first thing you should do is, sir, actually there will be a sound, click, click, click sound, right? We actually, we should not screw the micrometer until the click sound. Okay, we should gently hold it using just a thumb and index and rotate it. That's all. So if you click it, means that you are tightening it. We should not hear the click sound. Only gentle push. Okay, only until your fingers can twist. That's how you should push. Because what we are measuring in screw gauge is very delicate, right? Sometimes in electrical experiment, we will measure the diameter of the wire. If you push it until you hear the click sound, this will most probably cut or damage the wire. Okay. Also, it will mess with the screw gauge reading, because when you remove, when you unscrew it, it will not retract exact that much. Okay. Yes. So you should just, so it's freely rotate. Like you can just gently try to rotate it. If you cannot, leave it. That's your limit. Okay, that's one thing. Second, as soon as you receive the screw gauge, you should check the zero value in the main scale and the zero value in the pitch scale. This is circular scale or pitch scale. Should coincide. So your reading should be 0.00 millimeter. Yes, always. If you don't have anything, okay, this should be close with 0.00 millimeter. If it is 0 point some value, let's say 0.5 millimeter or 0 point, or let's say that shows minus 0.15 millimeter, meaning that this need to be calibrated. That's unnecessary. What you can do, just return this micrometer to the lab assistant or invigilator, ask for me. Yeah. Faulty experiments you can ask. Actually, the errors can be adjusted, sir. Just there will be a screwdriver knob here. So B minus flat will be here. So you just take the minus flat screwdriver and screw it or unscrew it. According to that, you will get 0, 0. Okay. Oh, I see. Okay. No problem. Okay. So if you have plus or minus some value, um, yeah, you can actually leave it, sir, because the Cambridge assessment gives you range values, not actual values. So if the errors are not bigger than, let's say 0.5 millimeter, you can leave it, no problem. Yeah, you can directly measure it. Okay. But make sure they do not exceed more than 1 millimeter or less than 1 millimeter. Okay. So actually, yeah, you can inform your teacher that this can be fixed. Okay. Yeah. So second thing is, for example, how many readings you can see in the main scale now? Okay, 7. So I should write 7 point. So now this is 0. This is 90. So you can see 1, 2, 3, 4, fifth line there. So 95. So this is 7.95 millimeter. This line, yes. Which line coincides with this line? That line you should know. Okay. So I'll give another one. Okay. 0, 1, 2, 3. Can you tell me what's the reading now? That's how you should read it. Okay. Yes, in millimeters. You should understand also, if it is, okay, if it is, now read it. So 46, 47. Can you see, if we wrongly read it, we'll get the wrong number. This also you should pay attention. In which side the readings increases. Okay. Actually, in the circular scale, 0 to 50 reading, you will not see the line, previous line. So you will not see the next line. But if it is close to 80 or 90, you will see the next line slightly. But you should not include that, because you are close to 80 and 90. That's why you are seeing that one. So you should not count that line. Okay. In general, how it works is, now let's say that this is beginning of the line. If you move this one full circle, your screw gauge will move 1 millimeter in this direction. Okay. If you unscrew this, it will move 1 millimeter in this direction. This is how the micrometer works. Okay. So actually, what is the least count of the screw gauge? No, 0.01 millimeter. Okay, wow. So can I write this into 1 to 10 into 10 power minus 2 millimeter? No, 1, 2, 3. 10 into 10 power minus 3 millimeter. Okay, so this milli is already, yeah, no. This is not about significant figure. Now, can you see it's the same value 0.01 millimeter and 10 into 10 power minus 3 millimeter. So this milli also 10 power minus 3, right? So can I write it 10 power minus 6 meter, or I can write it as 10 micrometer. That's why it's called micrometer. You can measure multiples of 10 micrometers. Okay. So screw gauge is general device. Micrometer, for example, ruler is general. You have millimeter ruler, centimeter ruler, meter ruler, right? Similarly, screw gauge is general name. You have micrometer screw gauge, you have millimeter screw gauge as well. That can measure only in millimeter. Okay. So you just have to, for example, last exercise I want to give. 10. Can you read this one, sir? Hmm. So because this is 0, meaning that we should assume this is 90. Okay, 82, 84, 86. Okay, sir? But actually, they won't skip this number. I'm just checking your understanding. That's all. Ah. Yes, everything. Yes, everything. Okay. Yes, so this is screw guards. Okay, so uh, we'll discuss this also the same paper. So ruler 3SF, protractor 3SF, micrometer or screw guards 4SF. This is maximum significant figures we can measure. Okay. Mm, yeah. So yeah, this should do. Okay. So uh, yes, there is. You can write no, there is no decimal place. Yes. Mm. Okay, good. Yes, sir. Okay. So for protractor, no decimal places. Yes, yes. Depend on what mode you're writing, but in centimeter, yes, 1. Mm. Okay. Is it clear, sir? Yeah, can we move on? Yep. Okay. So these are the general informations we require before practicals. So there are some rules that followed different to different schools. Okay, but I'm going to give what is the exact Cambridge uh, instructions. Okay. So first, student can ask to change for if there is any apparatus faulty. Is there any faulty apparatus? Okay. So this is rules and regulations of Cambridge practicals. Okay. So if there is faulty apparatus, the student can ask for a new one. Okay. So in the beginning is the better. Okay. the supervisor has to change the apparatus. Okay. Now let's say that person is doing practical. First question, 30 minutes, he is into it. Okay. And all of a sudden, the bars broken. Okay. In the tabular column, he is already into 3 readings. Now the bars is broken. From the new bars, let's say that he is issued new bars, and this bars, can he continue the fourth and fifth and sixth reading? So he has to start from early. So whatever the amount of time he spent will be given as extra time, and this will be reported as faulty or failure of experiment, failure of experimental material. So for this, students mark will not be detected. Reported as faulty apparatus. Okay, so that's one. No, no, no. It is completely depend on the supervisor. So supervisor can assess the damage of the faulty experiment, and he can, if he want, he can give the entire time, no problem. Okay, because in the end, if it's broken, it's fate of the experiment, sir. It's not fate of the person. Okay. Yes. Second, the student can ask for help, but this is only in the experimental part, not in the numerical or analysis part. Okay. But extension of this help will be reported and marks will be deduced. They will reduce 1 to 2 mark depend on the help, extension of the help. Okay. Help in the sense, for example, you do not know how to set up the experiment, or you have to measure theta from this direction, but you are measuring theta in that direction. Okay. In electricity, measure ammeter is connected in series, sorry, parallel instead of series. So like this setup mistakes, supervisors can actually advise student to change, but they will report it, how they helped it, to what extent they helped it. But mostly they will reduce only 1 to 2 mark, because in the tabular column reading, right, the raw reading has 6 marks. You will get all the 6 marks without any supervisor help. All have correct significant figures. If there is a supervisor help, you will get 3 or 4 marks. So you will use 2 to 3 marks in that one. Yeah, yeah, yeah. Yes, yes, yes. Okay. So, and you cannot do one experiment more than 1 hour. Yeah. So one experiment. So this is can't do one experiment. Okay. It doesn't matter. First experiment you finished in 40 minutes. If you want to take a second experiment, 1 minute, 1 or 20 minutes, they won't allow it. But what you can do, if you have the second experiment, second question as your first experiment, you can finish the question early, and you can draw the tabular column for the first question. Yes. No, it is better to first question. It depend on the person. Okay. If you're doing first question as first experiment, let's say that you do not have any, you should spend more time on taking reading rather than working calculation in first experiment, because you can finish the second experiment early, and you can write your calculation part in the second end of the second question. That time you do not need experiment, but there is a risk to it. Let's say that you have made some mistakes in measurement, you cannot undo it there. Mm, mm. Yes. Yeah. Okay. But I'll explain more on this one when we discuss the question. But this is a summary. Hmm. Yes. Okay. And you can take 2 to 3 minutes extra. That's not a problem. Okay. But more than 2 to 3 minutes, it's a difficult thing. Yes. Okay. So we don't want to pray more on this one. We'll jump to the question. Yes, sir. Okay. So question one. So question morely will have the tabular column part. Okay. So first you will measure some reading. Let's say that you are measuring x equal to this much centimeter. Okay. And theta is this angle, or diameter is this one, or time is this one, whatever it is. You are measuring this one. Okay. And you will find one value using whatever. For example, you will find pi x square or whatever it is. Okay. So this is one reading. Like this, you will do 6 set of readings. Okay. So we should draw a tabular column for 6 set of readings. Okay. What I would advise is take 8 to 9 readings. Okay. I'll explain what are this 10 mark contains. Okay. So this tabular column will be for 10 marks. Okay. So in this 10 marks, 1 minute, sir. Okay. So for the tabular column, you should give, for example, let's say that you are measuring x. How to write is x is a quantity slash centimeter. This is how you should provide the unit. Okay. And you should not write any unit in the row or column. Unit should be seen only in the column headings. Okay. Let's say that you are calculating area using x. Unit is centimeter square. Okay. Let's say that you have theta. You don't have unit, right? So you should leave it empty. Leave it empty. Okay. Degree. Sorry. Just degree. Okay. If you use cos theta, leave it empty. Yes, sir. Sometimes there is a catch. For example, let's say that you are measuring x. This is in centimeter. Okay. Now you have to find log x. Okay. Really? Okay. Paper 5. You will have paper 5. No problem. Okay. So if you put something in log now, it will not have any unit. So log doesn't have unit, right? So this is how they will try to write because it doesn't have any unit. But actually, how you should write is like this. Inside the bracket, you can write unit. Okay. Actually, this is yeah, yeah. This is more to paper 5. Okay. Yes. Then you should have significant figures accounted here. So as we discussed. Okay. Let's say that you are calculating. This also should have same or just +1 SF of this raw data. If it's more than +1, let's say if it's 5 significant figure, or let's say if it's 1 significant figure, they will lose mark. +1. Yes. Okay. No, actually I advise better to have +1. Okay, in the calculation. Why? In the graph, if you have +1, you can round it off to nearest digit. Okay. Is this clear, sir? Yes. Now, never ever give your answers in fractions in practicals or planning and analysis paper. No fraction answers. Why? Yes. So because fractions have infinite significant figures. So fraction means wrong. It doesn't matter the value is right. It's wrong. So we should never ever give fractions, and we should never ever round off one without, for example, some people intentionally round out because they have practiced rounding off in theory papers. It will just extend in practicals. Rounding off is also crime in practicals. Okay. So no rounding off. You should rounding off only to the significant figure. What this person is, one person actually he measured 3 significant values, rounded off to 2. His calculation also rounded off to 2. Wrong. Okay. Yes. And last important, okay, another one is range. So for this range, for example, let's say that you are measuring something length between 0 to 80 centimeter. A good range is 5 to 75 centimeter. Sometimes they specify the range. Yes, that we can follow. Okay. Let's say that, so for example, in some question, let's say that you have to measure the momentum of the ruler. Sorry, moment of force of the ruler. Okay. Clay is given and one side mass is hanged out. The first thing we should do is we should place the mass here and check what angle it makes. And we place the mass here and check what angle this makes. So we will get approximate range. You can, yeah. So you can just from that you can calculate what range you want to work out. Let's say that time period of oscillation. Let's say that you're starting from here, okay, pendulum, and then you have put another ruler here. So you can find this distance, right? So what's the maximum height you can do? What's the minimum height you can do? So you can divide the, so you can divide into equal parts so that you can give 6 or 7 values. Yes. Yeah, that we can do. But for reasonable amount, we can do it. Okay. Yes. So that's range. Mm. 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 Yes. Yes. No need. No need. No need. No need. Mm. Okay. For your satisfaction, you can write. It doesn't. It will not be carried for any mark. Okay. Yes. Mm. Yes. Also, if you write with 0, it will not carry any error also. So it's not a problem. Yes. Yes. Okay. So then, so this range, for appropriate range, you have 1 mark. Okay. So I'll actually distribute the marks here. Okay. So first 6 set of readings. For this, you have 5 marks. This is without supervisor help. Okay. Then for range, 1 mark. For column headings, 1 mark. Yes. With appropriate units. Okay. So you will measure 1 or 2 quantity, right? Consistency in those answers. All of them measure to same significant figures. All of them measure to appropriate significant figures. All of them. that contains 1 mark. Okay. Significant figures that contain 1 mark. Yeah. Significant. Mm, mm. All the calculations you will get 1 mark. Okay. Okay. Sometime this two they will combine into 1 mark. Sometime you will have instead of 2 readings, just 1 reading. So that will be compiled to 1 mark. So totally approximately you will have 10 mark or 9 mark. Okay. So what I would suggest is you take, if 6 is required, you take 7 or 8 readings. Okay. More. Okay. But within the range. There is very important thing that you should do. You should plot only. Uh, yes, yes, yes. Yes. No, 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 no. You should not give more. There is a catch to it. Yes. Okay. What we are going to do is we are going to plot graph, right? Let's say by God's grace, we got all the reading right. Not a problem. Okay. Let's say there is an anomaly. Anomaly means mostly we made mistake. So the time you remove that, okay, let's say that you remove the point. You just strike it here. You should remove there and you must definitely strike it here. You should not leave the reading here because 1 mark from the graph that says all the reading in the data has been plotted into graph. Please don't use pencil in practicals. Okay. Two problem. One, it will consume lot of time. So you have to write it again in the pen. Second, let's say that you erased it. What if it is right? If you erase any calculation, you will lose lot of time in redoing the calculation, even if you erase it by accidentally. Okay, you can, yeah. Okay, so strike it clearly. So just strike it clearly. So you do not need to worry. Okay. So writing in pencil, actually, even in higher standard experiments, more than the right values, they prefer the wrong values because they are interested in why they are wrong. So pencils does not play any important role in observations. Okay, so that's very important. Yes. Is that clear, sir? So this is 10 mark. Yeah. So you take 7 or 8 readings, but please make sure that you strike out 2 readings. Do not leave them here. Okay. Yeah. And so now this is the next part is to graph. Okay. Tomorrow, do you have any exam, sir? Okay. Yes. Okay. So second graph. Graph is for 4 marks, sir. So one, all the data plotted correctly. So that's contain 1 mark. And axis, both axis with units. This contain 1 mark. Okay. So the distribution of the graph. So the data distribution occupies more than 50% of the graph. You have to choose the scale in such a way. Yeah. But most of the time, this mark is combined to this. Okay. So this is true for both the axes. Okay. And yes. Mm, mm, mm. You should choose. No, no, no. Actually, if you can choose it between 70%, it's more than enough. You can do it. No problem. Okay. No, no. You should include that point. You should end your reading in 60 or 70. Okay. So just for example, your graph finish, you chose the axis in such a way, axis ends in 50, your reading is 51. You better extend the axis into 60 and 70. Please do not leave the point. No, but your one point is in that corner, right? So it's scattered. Not, it's not a problem. Because that point is there somewhere, right? Hmm. Um, that's not a good idea, but you will do it. No one will figure that out. But why to bother? But I'll tell you, we'll discuss how to choose scales. So you do not need to worry about it. Okay. Yes, sir. So, so remaining one mark for this, all the graphs are, all the dots are plotted less than half the square accuracy. Okay. All the plots are clear and then accurate points, and this contains one mark, accuracy of the plotting. Okay. Uh, so some, this also combined. So here to this point. Okay. And trend line. Yes. Line of best fit. So total approximately we'll get 4 marks, sometime 3 marks also. Okay. So now how to choose axis? Let's say that this is your graph. Okay. You have to make sure your data at least crosses this area. 50% is a requirement, but 70% is best. Okay. What you have to do? So take lowest of x-axis and highest of x-axis. Similarly, take lowest of y-axis and highest of y-axis. Okay. So high x minus low x. Here also high y minus low y. Count how many lines in x-axis, how many lines in y-axis. Divided by that value. I'll explain. I'll explain. Don't worry. Okay. 1, 2, 3, 4, 5, 6, 7, 8. X-axis will have 8 lines, 8 grid. Y will have 12, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Y has 12. So divide the X range by 8. Okay. So X range by 8. Divide the Y range by 12. Remember to round off before you divide. You do not take the actual point. If it is 83, take it 80. If it is 95, take it 100. This way, you will not struggle with the rational graph axis. Yeah, that's why. For example, let's say that you have 83. Okay. You should take round 90. Okay. Now, let's say that you are doing 30 from 90. You can't plot it here. Try to do it from 20 to 90. Okay. No need, no need, no need. All you have to figure out is the graph is scattered. That's all. So it's not necessary. You should start from 0, 0. No, you should not. You do not need to mention. You can just put the symbol here, but now that symbol is also not required. The king symbol. This means scales are not started properly. Okay. Yeah, yeah. Yes. No, no. You do not. You should not leave the point blank, sir. You should leave what is your first value. For example, x-axis, I'm starting from 20. You should write 20 here. 30, 40, 50, 60, 70, 80, 90. Right here, y value right here. 40, 60, 80, 100, 120. Okay, sir? Is it clear? Yes. So in this way, you will not miss a point. You can easily, you will not struggle what is single axis, whether it's 0 0.0, 0.25, 0.5. No. You just round it and find a good value. Okay, we are happy with that. Yes. Okay. Plus, how to find how much is one line? Okay. You should take this value, any major grid value, this value and this value. In this case, it is 100, this is 80. So 100 minus 80 divided by how many lines in it? 10. So this is 20 divided by 2, so 0.2. So each line, sorry, yeah, 20 divided by 10, so it's 2. So each line contains 2 value, 1, 2, 3, 4, 1, 2. So this is 82, 84, 86. This is how you should figure out each line is. Very simple, very effective. Because sometimes students make mistake in reading this line. Instead of 82, here they will plot 1, 2 here. So it's wrong. Yes. So you have to be more careful. This is how to find each single line, how much value it carries. Same goes for x-axis and y-axis. Okay. So x-axis, you should write unit here. Y-axis, unit here. Okay. For the graph, try to plot first in pencil, just the axis alone. And you can leave them into pencil. Okay. You do not need to work them. If you have time, you can work in the pen, but pencil work is recognized in graph. Yes, 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 yes. As long as because they are going to scan the paper, it will be forever. So no examiners will erase it. So you do not need to worry about it. Okay. Yes. Now how to draw the trend line? Okay. Now let's say that by God's grace, our distribution is like this. We can just put a straight line. Yeah. But this is not going to happen. Okay. So this will go like this. Okay. The very must thing you should bring to practical, one calculator, another 30 centimeter transparent ruler. Okay. So you should have ruler like this. So just not more than 2 centimeter width. Buy a normal 2 centimeter width ruler, 30 centimeter ruler. Okay. Put it on your graph. You should see all the point through your transparent ruler. Without changing any angle, move slightly back between the points. Make sure you can see half the point above, half the point below. You do not need to even touch one point. Okay. You must see all the points through the ruler, adjust them so that you have to adjust in this theta, right? Adjust them, you can see all the points here. Okay. Do not change the angle. Bring it back so that you can see half the point above, half the point below. Draw the line throughout the graph. You should draw all the way above and below. Okay. That's your trend line. Line of best fit. Okay. If there is some line you cannot accommodate, round it anomaly. Okay, remember, if it's anomaly, most probably you made mistake. No. If in this case, in the case of you just took six reading and this is anomaly, you should mention this as anomaly. You should not strike it out of the graph. You have only six reading means you should leave it. If you have only five reading means you will lose 1 mark for not getting six readings, sir. If you have only six readings and that's anomaly, you should circle it and mention it as anomaly. Okay, so they will not deduce mark for this because you have mentioned this as an anomaly, experimental error. But if you strike it off in the graph, sorry, from the tabular column, you will lose 1 mark. Okay, so that's why we are plotting 7 to 8 readings. If it's anomaly, in this case, you can remove. Okay, now what is the point of extending this trend line above and below is one, no. Second thing, we should not find the y-intercept directly from the graph. Then we will come back later. Okay. Now let's say I need 2 points for gradient, right? I can take this point and I can take this point where they cross major axis. Any axis is right. But this reading you can easily read, right? Because it's a round of number. Yes. If it goes like this, you can read just this value and this value. If it goes like this, you can read just this value, this value. This, yes, for two reasons. One, you know this reading, this is a round of value very easily. Okay. Two, anyways, for gradient, your length of separation should be more than half the length of the line. So why to bother inside? Yes. Make sure you draw the triangle, whether you can see them or not. Okay. Is that clear, sir? So for gradient, two mistakes commonly people make. One, forgetting if there is any 10 power 4, 10 power 3. If it is centimeter, they will forget 10 power minus 2. If it is millimeter, they will forget 10 power minus 3 in the unit. If you give your gradient unit also, okay. So how to find unit of the gradient is first question. Okay. So, yeah, gradient is m. So you will do y2 minus y1 divided by x2 minus x1, right? How about the unit? Y-axis unit by x-axis unit. Okay, sometime y-axis they will not have unit, so you will just have x-axis unit inverse. Sometime x-axis will not have unit, you will have just y-axis unit. Yes. Yes. Okay. So second, y-interceptor. Okay. So this is the common mistake most people make is if this is a graph, x-axis unit, y-axis unit. Okay. Just read this value as y-interceptor denoted by C. This is wrong. Okay. Then definitely you will lose 2 marks. Okay. Okay. This is wrong for two reasons. Only if your x-axis scale start with 0, this is right. It doesn't matter. முடியாது. முடியாது. No. What is the definition of y-interceptor is when the line crosses when x equal to 0. So if you are not starting x equal to 0, that is not your y-interceptor. That's a random point. Y equal to, you have to use y equal to mx plus c. Okay, you know the gradient value. You can rewrite equal to y minus mx. You just randomly take x comma y. Please do not take the same point as you took for gradient. This will also work. Okay, but If there is an error, this will multiply your error. Okay. So try to take any random point in the major axis. Easy to read. If you cannot find one, then take minor axis. Yes. So take this point and put them here. You will get y interceptor, and y interceptor have the same unit as y axis. So sometimes people draw their tabular column to. That's not necessary. And even if you do it, it won't be perfect. Okay. You should plot this way. Do you understand this method, sir? Yeah. Yes. Okay. So if you directly read y axis, y interceptor, that is wrong because x is not starting in the 0. Okay. Even when the graph is like this, sometimes people will draw, just try to extend and go like this. This is wrong because x is not equal to 0. This is wrong. This is right. Okay. Yes. Now let's say that for some graph. Okay. Is it clear, sir? Yeah. Uh, let's say that you are measuring theta versus x. Okay. Maybe cos theta versus x. Yeah. Cos theta versus x. Okay. So the cos centimeter. Okay. So the gradient will have unit of centimeter inverse. Hmm. Y will have no unit. Okay. The next page, they will give something like this. Cos theta equal to ax plus b. Okay. So, and they will ask two values. Without any change, you should write the gradient value. You should write the y-intercept value. So that's the purpose of the reading. Without any change. Yeah. You don't round off. Actually, the gradient and y-interceptor, they don't carry marks for unit here. Yes. Without unit, if you write gradient and y-interceptor, they are not going to reduce mark. But here it is necessary. Yeah. So it's better give there also. Okay. So you do not change any value from there to here. All you can write is y equal to mx plus c. So m is a. You will get 2 mark. You will get 2 mark. Yes. Let's say that your gradient and y-interceptor that I'll explain later. Okay. So what you have to write here is y equal to mx plus c. So m is a, c is b. That's all you want to write. You do not need to perform any calculation. You do not need to do any numericals. Just write the gradient value and y-interceptor as it is. Actually, I have never seen a question that they ask b first and a second, but just look out. Yes. Okay. So, and few questions have some aftermath after this, carry for 1 mark or 2 mark, but most questions they won't have. Okay. But that's not necessary. Yes. Is it clear, sir? Now, the very important thing you must understand is it doesn't matter whatever the mistakes we will do, we will get mark. But people panic, out of panic, they lose mark. For example, okay, I'm going to say the worst case scenario. Okay. So 10 reading you're measuring, right? Sorry, 6 readings you are measuring in the tabular column. Okay. So let's say that I have to measure this angle, theta, from here to here. But instead of that, I measure this angle from here to here. Can you see that this is a very big mistake? Will change. Okay, wow. Actually, you are making your experiment completely opposite. but you will lose only 1 mark for this mistake. Which 1 mark you will lose? No. In the tabular column, this reading mark you will lose. Using I'll explain why. This reading is wrong, right? This reading, but provided you should give correct significant figure. That's very important. Okay. This reading is wrong, but using this reading, you calculate this value, right? For this value, if your this value is right, you will get this mark. Yes. And this exact values you have plotted in graph, so you will get that mark. Yes. Axes are right, so you will get that mark. Can you see axis is independent of that value? Gradient and y-intercept is independent of that value. So you will get all this mark. What mark you will lose is only if they have this part, right? For example, let's say that here is you have to find the acceleration due to gravity using your reading. If you make any mistake, you will lose this mark because this depend on that answer. Otherwise, you will not. So what people do is sometimes they will see the plot graph is for all the others is this. They will have this. All of a sudden, they will panic and erase everything, but they don't have any time to redo it. It's better to leave it. Only if you can redo it, please erase it. Otherwise, please do not erase it. Okay. Also, please carry 2 different colors of pen to the exam. Even if you are having black color pen, carry 2 different shades. Okay. But I suggest you carry 2 color pens because if you are doing something wrong, you can just erase it. Let's say this is emergency situation, I'm telling. Instead of erasing it everything, you just write out black, strike out all the black, start writing in blue. So the examiner will understand blue ones are the actual one. Yes, just in case. But this is pray for best, prefer for worst case. Okay. Yes. Okay. That's your first question. Do you have any doubt in that first question, sir? Yes. Yeah. Yeah. Very clear. Okay. An intelligent person for some question need not to touch the experiment to do his calculations and readings. Okay. Yeah. So for example, let's say that they are asking G, you can just put your value 8 meter per second square or 12 meter per second square and work all your way up. Yes. Okay. But this is not a right thing to do for practicals, but this is to a proof check, full proof way. So make sure that you don't commit any mistakes earlier. Okay. Yes. So that's our first question. Maybe take 5, sir. Okay. Come back by 7:50. Yes. Yes. Thank you.